Hello and welcome back to another festive coding session with Mr. Jacob. Today, on the 5th day of December, together with my trusty Grinch mug here, we will tackle the next language in our Advent of Languages, where we decided to implement each day of the 24 days in December until Christmas the same little program in a different language. And the program is essentially this one here, where we take this Christmas ASCII art tree, or kind of this tree. Let me copy that quickly into the clipboard here for later use, and print it as an ASCII art onto the terminal. And today we will actually go and do that in Haskell. And I have already prepared a little make file here, only to have this quickly build and run in a Docker container for me to ease things in order to get this running quickly with you today and concentrate on programming and not on setting up this environment. Because I don't really have Haskell installed on my system, because I usually don't use it. The last time I guess I used it was in university, really long time ago. There I really used it, and I have done some Haskell stuff in between, but not much. So I've quickly set up this Docker file, this make file, which then compiles us the Haskell thingy. I know it's not the usual way to handle Haskell thingies and Haskell files and Haskell projects, but for this minimal project, it was the quickest thing I could do to get going. And so let's do that and let's get going. In Haskell, usually you have this main module, and therefore we call the file main.hs. I think there is no real need to do that. You could name it however you want, but I think main is a good thing here. It will then, by the make file, compiled into the usual hello Xmas executable. Okay, so first of all, let's paste in the thing that I just copied, the tree. Let's go and comment this one, and let's remove the spacing here, just so that we have something to reason about when we are actually thinking about how we are going to implement that. And now we need to start with our kind of entry point here, which is in Haskell always in the main module. So I tell it that I want to define the main module where there is some content. And whoa, what was that? And Haskell is a very functional language. It's essentially a basic functional language where everything kind of is a function, and we are transporting some information, like, for example, output through monads and stuff like that. That is not really important here. What is important is that we are doing this with a lot of functional reasoning, because we can't really have this structures like do this and then do that and then do that and then do that. There are ways of doing the things like this in Haskell, but usually it is better, or we want to do in this simple session here, to do it the functional way as far as possible, with my at this point in time very limited knowledge of Haskell, because, as I've said, I'm not usually using Haskell, but I guess we can get going here. So we now have this main module, and we need a main function. And for first of all, we need a type definition for that. And we simply tell it that it works with the IO monad. So that is actually what we are doing here. We are defining a main function. And now, as everything in Haskell is functional, and therefore functions are first-level citizens, we can simply use them as expressions and assign them to, for example, in this case, variables. So what I've done here is I've kind of assigned to the main variable. That's not really true, because we are not in a function yet, but I have assigned to main now the function, or I'm going to assign the function. And what's there after the equal sign is essentially that what the function will in the end return when it is run. So we tell it to, for example, do something like print line, if I remember correctly. Let's see. Hello Xmas. Let's see if this works at all, and let's try and compile this using the make file there, and it does not work. Okay, variable not in scope, print string line, string to the IO monad. So essentially, oh, put string line. Put string line it seems to me, put str line. I'm very confused that I even remembered something like print str line. Okay, there it is. Hello Xmas. So we have basic output capabilities using this IO monad. And as I've said, I will not detail monads here because that would fill a couple of hours mostly. So we can kind of use that as an exit hatch to print something to the terminal. That is actually nice to know. Now, what do we actually want to print here? Let's start with our, as always, with our groupings. So we have these tree groups, this one, and wait, I did scroll somewhere, and this one. So we have the first one, the second one, and the third one. So we define simply now another function, and usually we called them print group because we were directly outputting stuff. This time, the only function that will actually do outputting will be our main function. So the other functions will simply return some sort of data structure, most likely a list, I guess. Haven't thought that far into the future yet, but I guess we will return a list and use that to print out the lines so that we can actually, or to transport them through the application so that then the main function can actually print them out. And please bear with me if I'm doing something wrong here. I'm by no means a Haskell expert. So if you know a better way or a nicer way, please let me know in the comments. So that others might find the interesting facts as well. Please always be polite, and then we can communicate there, and you may know things better than I do, so please leave me a comment there. Okay, so I guess because we are only creating this data and not printing it directly, I guess I will call this thing make group. And make group in our case usually takes an integer and it takes another integer. So it usually takes the n, the number which is currently the group that is currently creating, as well as the maximum number of groups that it will be creating. And it will return in the end, I guess. Yeah, I said we could do this with lists. So let's maybe do that and return a list of strings. So we can return our lines simply in this list syntax. And actually, that's a quite interesting thing here, how functions are defined in Haskell, because this is kind of currying. So what this means is that this is a function which takes an integer and returns a function that takes an integer and returns a string list. And this function that is then, so to speak, returned will then take this integer and return the string list. So you can actually kind of split this up into multiple functions that then can be nested into each other. And I have no idea how this is actually internally done in Haskell anymore. That's too long in the past. But essentially, that's the concept of currying. So if you are interested in that, take a look at that. It is essentially the concept that you always only have a function which takes one argument and you can then nest them together to actually create what you want there. I'm not saying that this is how Haskell does it internally. I'm just saying that there is this concept of currying, and you might be interested in that because that's the way how it is kind of written here. Okay, so now we have this syntax here. So let's define make group. And now we can do some sort of pattern matching here by saying, okay, if we have a make group call there, and this make group is called with n and len there, then we have this function body here. And this function body now should actually create our list. So let's first of all, how did I go down there? So let's okay, this Haskell mode here is really, really strange. Let me quickly open up this thing again. I did something very wrong in this Vim mode. Okay, So let me create this list here, actually, where we now simply define that we are returning when make group and lang if called, we are returning a list of strings. And now we need somehow create our list. And I guess we want two lines there, as always. We want, first of all, a line containing this spacing here, and then we want this, we want the slash, and then we want the inner spacing there, and then we want the backslash. And I guess we can do that. And there is a neat little function in Haskell which we can use to actually replicate or repeat certain characters to create a string. Or better said, it can be used on any list to create the elements of the list, to repeat certain elements of this list type that we are creating and put together a list of these repetitions. And as in Haskell, strings are actually only lists of characters, we can use a character and repeat it over and over again to form a new string like we want. And the function is called replicate. And it works like that. I'm doing replicate, and then I'm telling it how many replications I want. So what I want here is obviously, I want, as always, len minus n replications for spaces. And then I tell it that I want the space character there. And then it will create a list of these characters times len minus n. And this will, of course, be a list of characters. And a list of characters is essentially a string. So now we have a part string. So now how do we concatenate it with our other part of the string? We use the list concatenation operator because we are just concatenating one list of characters with another list of characters. And therefore we can simply concatenate those two lists together and then have a new list of characters. So what I want to do here is I just put there the slash, and then we do the same thing with the inner spacing. So we do replicate, and we tell it that the inner spacing, as always, again, is n times 2 spaces here, and we want a space as well. And then we concatenate that with a backslash. So that would be our first line. So our second line then would be the same thing, but with one less spacing in front and with, as always, n plus 1 times 2 spacings in between. So now we have this make group, and it gives us a list of lines, kind of. So how would we actually call that? Yeah, we could directly call that here, but let's not call that directly, but use a variable for that. So what I want here is, let's call this, I don't know, top part maybe. We are printing now the top part, but where and how do we define this variable? In a language where we have this processing of do first this, then do that, then do that. So an imperative language, we could put it in front, but we can't, because the execution of the main function needs to be one expression. So there is this neat concept where we can say where, and in the where block we can actually define variables which need to exist within this execution of the function. So we can now tell it that we want the top part here when we execute this actually, which should be make group with let's do, I don't know, 0 and len 5 for now, just for testing purposes here. We of course need to do kind of a loop there. Later on we will see that in a second, but this should now actually maybe work. Let's see if it does. I have no idea. So no, it does not. Okay, parse error on input. Wait, what? Line 18. What's the problem with line 18? Where is line 18? There is line 18, and the problem is that there is a comma there at the end. Okay, so no, I wanted to do a recompile. And now we have another problem. We have the problem that, it couldn't match a list of characters with characters. So it expected a string, and it got a list of strings. Yeah, that's actually right, because our make group returns a list of strings, and we put it directly here into top part and kind of tried to directly execute that, which is, of course, a problem. There is a function in Rust, not in Rust, in Haskell, sorry, where we can do combine a list together into so we have a list of strings, and we can actually combine this into one list of characters, so essentially one string, and divide all of the different elements by a new line. And this function is called unline. So, or unlines, better said. It's called unlines because it is the inverse of lines. Lines usually goes ahead and splits a string up into a list of strings, and unlines therefore is the direct thing which does the inverse. It goes ahead and takes a list of strings and makes it one string again. So let's see if this now works. Doesn't work. So probably cause unlines is applied to too few arguments. In the first expression of put through a line, namely unlines. Okay, what's the problem there? Expected string, actual string to string. Couldn't match. That's interesting, actually. So did I put it at the wrong position? Let's quickly see. What I did here is I have this make group, and make group gives us a list, and this list I actually want to put into unlines, and this I want to put into there. So we should actually need maybe do we need to put braces here? Yeah, we need put braces here, but then there is a neater syntax there. We can actually do something like this, I guess, which is kind of the Haskell variant of what I just did there. So if I do this, which would be like call this put through line, then in this one use as an argument the return of the unlines function, which you call with the argument top part, and I can write this using this dollar notation, which is just a little bit neater in cases where we kind of wrap those stuff and concatenate all of that again. So this is essentially what it does. It is right associative, so it goes ahead and says, okay, I take the top part and evaluate that first. Then I put that into unlines, and then I put that into put through line. And now I have explained all that, and most likely now this will not work. We'll see. Okay, it works. That's nice. Okay, so now what we need to do is for this top part actually, or this top part, we need to kind of make the group, but we need to make multiple groups because we want to do 5 groups, I guess. So first of all, we could define something here in our where part where we say groups is 5, because I guess we will need this a couple of times. And now how do we actually do loopings or loops in Haskell? There are a couple of ways to do this. In most situations, or in a lot of situations, you use list comprehensions. So you are actually defining an expression which in turn converts into a list. And this actually makes things, or this is a very, very capable and a powerful feature of Rust, where I can simply do something like, I can now tell it to make group n here, and I tell it to use groups as we have defined it before. So it actually creates a list calling make group with an n argument and groups. But now you ask, where does the n come from? The n comes from by defining it just in this list body to create this comprehension. So what I can tell it now here is, let me close this list there, that I want the n for this thing to be created using this expression, and this expression is another list, so that I can say, okay, for each entry in this other list, create an entry or comprehend this together, flatten this together, and create a new list, which is determined by evaluating this then. And this list actually is simply 0 to groups. And as these ranges in Haskell are actually always including the end element in comparison to Rust, for example, where this syntax would create you something that excludes the last element, we need to tell it that we only want to do until groups -1. And if I did this correctly now, the result here should now be a list of those lists, so of those lines. So that's not what we want. We want to kind of flatten this down to only a list of those lines. So what we do in front of that, we tell it that we want to concatenate all elements of this list, which essentially goes ahead and takes all of the elements out of this list again, takes them and concatenates them with each other. And if you do that, you have essentially flattened the list by one level. And that's hopefully how this goes. Let's see. Okay, and this is how we create our top part of the tree. So now the most complex part is actually done. Nevertheless, what we could do to make this here a little bit more readable, we can now essentially use the fact that we can define variables with a where and define us something here which we might call, what did I do there again? Go back, I don't want that. Yeah, I already am in a strange mode here. Let me go out there again and go in there again. Okay, so this Haskell mode is really strangely configured. As I've said, I'm usually not using it. So we can actually do this where here, and we now say something like spaces maybe, and we define ourselves a new function here. That is something that I wanted to show quickly. We define ourselves a spaces function here, and this spaces function could more or less use this here to do this, and we do not need to specify the spaces everywhere. So what we could do here is something like, we could say the spaces function is actually the replicate function. And then we take into the replicate function somehow this argument. However, if we do it like this, if we just do this, then we have a problem. Now, if something is specified to spaces as a first argument, it would be put here at this position, which would be the wrong position. So there is a neat little trick. You can actually use the flip function, which simply flips around the thing that is then, so to speak, provided. So if we do flip replicate this, then we can actually do spaces, and we simply provide the amount here, and we do spaces, and we simply provide the amount here, and we can do spaces, and we simply provide the amount, and here the same thing. Let's remove that, and let's rename this to spaces. And now this should work exactly the same thing. And this is essentially, again, this this kind of currying thing that I said here, where we can simply say, okay, spaces is something like a function call to something, and it will simply take this, even if you supply another argument like this one here already, and it creates then a new function there, which actually has this one argument incorporated. That's actually a really neat trick. So let's see if this is still, no, I didn't want to exit it. I wanted to make run. That is still running, and it is still running. And as you can see, it's correctly creating the spaces. So let's wrap this quickly up, because we have already reached our time limit. So what we want now is essentially, we want this dividing part, so we can actually do that. Let's call this divider, and let's do simply use our replicate function for that. So we create a list, because we always want a list. You will see in a second why. We do simply replicate, and we replicate like, what was it? Groups times 2 plus 2 times the minus character here, to actually create the this division bar there. And why are we doing that as a list? We are doing that as a list because now in this part here, where before calling unline, we can actually do list concatenation with the divider. So it takes the other list and concatenates them together, and now we have the next line simply added to our list before it is then later on pumped into unlines to be executed there. And after we have the divider, let's quickly see that we did that right. It should now display a divider. There it is. We need the trunk. So let's quickly define that we want a trunk here. And we can use list comprehension again if we want to, for example, to do this 2 times, or we could do this another way, but why not? Let's use list comprehension for that by creating a list, which now needs to be 2 entries, 2 lines of our trunk. And in every area of this thing, what we want is we want replicate, and we want there the amount of groups there as amount of spacing with a space. And now we want that concatenated with our trunk string, so something like that. And now we want this as a list of 2 entries, so 2 lines. And what we can do there now is we simply use a list comprehension. However, we don't map this comprehension to any variable because we don't really need that. I'm not 100% sure that this will work, but I think I remember that this is at least possible. I don't specifically know if it is possible to do that this syntax way. So there might be another way to do this. We will see in a second if this works. Otherwise, we will do it in another way. Okay, so we don't care about the variable, and we want now to go from 0 to 2, but we do not want to include the 2. So we could say go from 0 to 1, but there is another syntax there which tells it to not go, or to stay less than the end here, which unfortunately does not work if you have variables here, as far as I know. So it only works with literals. So let's actually add here into our comprehension the trunk as well, so that we now have our tree consisting of top part, divider, and trunk. Let's save that and let's run that and let's see. And of course, this list comprehension does not work. So what would happen if I simply put an X there, which I then do not use? Okay, variable not in scope. Okay, so maybe this does not work. I have no idea. I thought it would. Okay, so this way it does. So what I most likely can do is just rename this into an underscore, and then we are fine. Yeah, as you can see now, we have our Christmas tree rendered here in Haskell, and I can change the groups and make this again, and we get a bigger tree and a nicer tree, and yeah. And as you can see, we kind of did this in a very functional way, where we did a lot of list manipulations and list concatenations and stuff like that. And this is usually essentially really the way that you are doing a lot of stuff in Haskell. You are using lists, you are using pattern matching. We didn't use that much of pattern matching here. You are using list comprehensions and stuff like that to realize all those functional concepts and to use these functional concepts. And as I've said, there is a sort of imperative style of Haskell that you can actually do to execute things one after each other, but we didn't use that here. And yeah, that would kind of defeat the idea of doing a functional language here. Even though this video was a couple minutes longer than the ones before, because I needed to try and explain some things, and I'm not that fit in Haskell as I am in other languages because I usually don't use it. I still hope you liked it and will join me for our next day when we are doing another language there. So I hope to see you tomorrow in our Advent of Languages. And if you liked this, please give the video a thumbs up and leave a comment there if you have any questions. So I hope to see you again soon. Bye!